Alrighty, now that we got that out of the way, we can go ahead and get started with today's video. So in this video we're going to dive in deep and figure out the root cause of the failures of these two old shift solenoids that we pulled out of an '06 Acura TL. So let's get into it. One of the first things I'm going to do to check the functionality of these solenoid valves is to check the resistance through the coil. If you're not familiar with what these are, there's essentially a copper wire that's wound up a whole bunch of times throughout this section of the solenoid, and that's when you send a current through it, that's what provides the magnetic force to shift whatever poppet or ball or body that you have inside these solenoids. What happens is, especially in places with cold winters, your valve may be sitting at 0 degrees Celsius or a little bit lower than that when the car is off, and when you turn it on and get up to operating temp, you might shoot up to 100 to 125 C, maybe a little higher than that depending on the car and the engine that you're driving. So what happens when you change the temperature of a material like that is you get this fatigue from that thermal cycle, and that fatigue can actually lead to a break in one of the wires in the coil. So what we're going to do is check the resistance to see whether or not the coil has a wire break in it. So we'll go ahead and put our multimeter to the resistance setting here. I just got these little alligator clips because I don't have a spare connector for these guys. But what I'm going to do is hook up each alligator to one of the pins. See if we can get a resistance reading. So you can see this one is about 16 ohms, which seems like a pretty decent number. I would expect a solenoid like this to be between maybe 5 and 25 ohms depending on what size wire and how many turns they have inside there. So 16 seems like it's within whatever spec the manufacturer designed this valve at. But we go ahead and check the other one. Okay, wow. Yeah, so this one we're seeing about 30 mega ohms, which is 30 times 10 to the 6th ohms, which is essentially telling us that this thing has extremely high resistance and most likely has a wire break somewhere within the coil. The next step with these guys is going to be to go ahead and open them up. So, wow, this thing's terrible at focusing. But anyways, we're going to go ahead and decrimp these by either prying this crimp tabs open or just go ahead and cut this part of the housing off to pull the internal components out. So let's go ahead and do that. So I'm going to go ahead and decrimp the bodies, see if we can figure out why they failed. I've already tried on the other one to decrimp this flange that's rolled over here, but I couldn't do that with a screwdriver, so I'm going to use a rotary tool and cut that crimp flange off to separate the parts. So when I was cutting the crimp flange off of this one, this thing kind of just shot off, so I wasn't able to catch that on camera. But taking the parts out, we have the body here with the mesh filter on the nose, O-rings on the side, and our work ports here. We also have this pin that came out of there with a small little washer or shim that was on the end of this guy here. This sat down in the housing of this solenoid, pressed up against that spring there, and then this body was pressed onto there. So we'll pull the coil out now, see what other components we got in here. Looks like we're clamped on the coil a little bit. So here we have the copper coil with the connector and the plastic overmold around it. Let's see if we can get any other components out of here. We got this spring that was pushing on the pin here on the back side. They'll get anything else out of here. Nope, that just looks like there's a O-ring in there around this housing. So if we look at the way this thing came apart, this spring here was pushing on the back side of this pin, armature assembly type thing. Since the spring's on that back side, it's biasing the armature assembly out basically, which leads me to believe that the way the coil is wound causes a magnetic force that's down this way, so that when you energize the coil, it shifts this armature pin combo down into the spring to open up a different flow path. What we're trying to figure out now is how this body actually works, so that when this armature is moved, how that actually changes the flow of transmission fluid through the automatic transmission and basically causes it to shift into the next gear. So that'll be the next step, just tearing this open and trying to figure out how that all works. So what we're going to do is cut the flange on the nose of this body so we can pull that mesh filter out and see if we can get a better look at the internals of this body here. So we got the crimp on that nose filter cut off. We're going to go ahead and take the filter off and just lost a spring. So the filter here looks like it's sandwiched into two little pieces of metal here, and it's pretty deformed, so I don't know if I did that just now or... But yeah, that's that. Got a spring in here, super low force, barely any resistance there. Oh nice, you can see there's a ball in there. Well, you can't really see it, but there's a really tiny, what I'm guessing is a stainless steel ball down in there, and that's what this pin would push on when it's shifted from the other side. It's going to push that ball up and open a flow path from in through that nose filter and then out to one of these two work ports, depending on where this thing's shifted to, I'm guessing. We're going to go ahead and chop this thing in half and see if we can get even a better look yet. Alright, so we got this thing cut all the way through on both sides, and then I went ahead, popped the screwdriver in there, pried it open. Now we're going to take a look at what's inside. Probably have to clean it out a little bit to get a better idea of what's inside there, so we'll go ahead and do that off camera. So now that we have the body cut open and cleaned up, we can take a little look inside and see if we can figure out how it works. If we take a look at this half of the body with that brass sleeve, brass bushing in there, we see that the armature assembly fits in like that. We also see by looking at the armature assembly that there is a reduced section of the shank that goes down to this small pin tip with this fillet here, and that fillet actually seats down on a land inside the body, which is right here. So it seats down on that and actually seals off to allow or prevent flow from coming in through the nose and then into this bore and out this larger side window. So that's one of our sealing surfaces there. Then if you take a look at our steel ball that came out of there, that was down in the end of that bore like that and had this spring pushing on it from the end, which was preloaded by that nose filter that we cut off earlier. And just by feeling around with this body, I noticed that when the armature assembly is fully seated down this way from that back spring force on the armature assembly that was from the housing, the ball isn't actually seated on this land, meaning that flow can come in through the nose, so we can have supply pressure and flow in from the nose and then out this side hole here. And then when we energize the coil, that's going to shift this armature assembly back this way, which is going to allow the ball to seat on that land there from this spring force on the end of the nose, and also open up this flow path here which was sealed off by that fillet before. So now we will have reverse flow in through this small window back into this bore and then out this tank drain here, which is the smaller window there. So that's kind of what we figured out with the body so far, and we'll go more in depth into that in the next shift solenoid video, but for now that's what we figured out. Alrighty, so we got that first solenoid torn down, and now we are back up at the desk, and we're going to try and actuate the second valve with our DC power supply and see if we can observe that armature assembly shifting inside the body. Alright, so we're going to go ahead and turn our DC power supply on. We're going to set it to about between 12 and 13.5 volts, should be fine. So we will pick up our solenoid here, throw our alligator clips in on the terminals inside the connector. Alright, so we got one of them on there. Try and put the second one in. Oh yeah, she's definitely shifting. So you can see as I touch the second alligator clip on and off that terminal, you can see the armature in that smaller hole there in the body. You can see the armature shifting back and forth. So when I energize it, it's pulling that armature up toward the coil, away from the nose of the body. And then when I de-energize it, you can see that the armature shifts back down from that spring force that we saw when taking apart the other one. So to summarize a little bit of what we've found so far, we tore down the first solenoid, which was the one with the brown connector. This one here is the black connector one. But the one with the brown connector, we measured the resistance to be extremely high. That one was the one that was up around 30 million ohms or whatever it was, basically telling us that we have a wire break somewhere in our coil or somewhere in our circuit. We didn't see anything too out of the ordinary with tearing the rest of that one down. So with that brown connector solenoid, I'm pretty confident that we can attribute the failure of that valve to the fact that there was a wire break in the coil, making it basically not function and not shift the armature assembly back and forth because we weren't completing that magnetic circuit. This one here, which was the second one, we haven't torn down yet. This was the black connector one, measured in around 16 ohms or somewhere around there, and we just powered that up and we could observe it shifting the way that we would expect to after knowing what we know from tearing the first one down. So I'm not actually sure if this one is faulty or not, if this one's actually failed. I was doing a little reading on the transmission for this car. So with these, there are some situations where these shift solenoids interact with each other. For example, you might close flow to one, open flow to another to shift to another gear. So some of the codes aren't very specific by telling you which one of these solenoids is actually broken. It'll basically tell you two of them that could be broken and one of them might not be. So that's why I'm thinking that since this one's operational and we have seen a reasonable resistance value, that there's not a huge point in tearing this one down. I think that this one would be okay. I'm guessing that the main issue in the car was the other one, because if that one failed, the transmission wouldn't be able to shift. In one of the next videos, I will reverse engineer the parts that we tore down from the other valve, and we'll go ahead and make a CAD model of that, and we can walk through virtually on the computer kind of how this thing's going to work. So I'll go through and explain the different considerations with these, some of the parts, and basically just the internals of these valves, and it'll be a much cleaner explanation with that CAD model than it would be trying to show you these rusted cut up parts. I'll also try to introduce a little bit about the transmission and how these shift solenoids actually interact to shift your transmission when you're driving down the road. But that's going to be all for this video, so yeah, stay tuned for that next video when I'm going to go into depth on how these valves function. Thank you.